Hey, mathematicians, today we're going to learn how we can take a graph like this and we can use it to write an equation like y equals x times 2 or y equals x plus 3. And we'll see how this table serves as our middle step between the graph and our equation. So let's dive into our first one here. You can always check the title for our graph to make sure we understand what we're looking at. This says trees planted per day. So you see down along the bottom are our days. That's usually where we're going to find our time, and then our y-axis shows how many trees are planted on each one of those days. Now, I can't just look at this graph and dive in and write an equation right away. I'm going to have to figure out what is happening to my x and my y values each time. And that's why we would record things in a table so we can study those x and y values. So let's take a look at what some x and y values would be. We're going to find our ordered pairs. I'm going to start along the x-axis first. If I go over to 1 day, and then I follow up to see where my line in my linear equation hits an y value, you'll see there's a point right there at 1, 2. And what that 1, 2 means is on 1 day, there are 2 trees planted. So I'm going to record those x and y values. 1 is my days along the x-axis. 2 is the number of trees that are planted. I'll just continue doing that until I have my table filled out. It's usually good to aim for about 5 values if you can. Then the pattern should be pretty evident to you. So my next value, if I go over 2 days, you'll see that there are 4 trees planted. 3 days, there are 6 trees planted. You might already see the pattern. Do you see it? If you go over to 4 days, there'll be 8 trees planted. And then 5 days, you can see that one's actually labeled for us already. 5 trees or 10 trees planted after 5 days. So I'm going to record those values. So we had 2, 4, 3, 6, 4, 8, and then 5, 10. Can you see the pattern yet? So I'm recording those over in my table, and I'm just pulling the x and y values from my graph. So let's take a look. When we write a linear equation, we always want to say y equals. I'm going to go ahead and put down an x over here because we are doing something to the x to turn it into the y value. So 1 becomes 2, 2 becomes 4, 3 becomes 6, and so on all the way down to 5 becomes 10. So here's a mistake. I could say, oh, it's y equals x plus 1 more, right? Because 1 plus 1 more gives us 2. So I could say plus 1 more. Does that work for my next set of ordered pair? 2 plus 1? No. 3 plus 1? No. So it's got to work for everything in the table. We probably know that from 5th grade when we're finding patterns. It's got to work each time. So what is the pattern? Think multiplication. We're going to say y equals, well, you could think x times 2. And the way we'd write that algebraically would be y equals 2x. Because each one of these instances, we are multiplying x times 2. So think about this for a minute. What if we added a 6 as an x value? What if we went over here to the 6th day? Can you predict how many trees would be planted? Well, if we follow the same rule of 2 times x, or x times 2, 12 would be the number of trees planted. Here's our second example out of our 3. When you cook certain things, certain items have to be cooked longer. Like if you're cooking a turkey for Thanksgiving, you want to cook that longer than, a cheeseburger or something. So if you check out this graph, it says time required for cooking a roast. This is a little unique because hours are on the y-axis and usually they're along the x, but we can still use it. Again, what's our middle step? Can we jump right to the equation? No, we need to fill out a table first. So I have pounds. How much does this roast weigh? And how long should it be cooked? So if I go over, I am not going to put a 1 in my table because if I go over to 1 pound, if I go up to my time, where is that on my y-axis? Well, maybe it's a half, maybe it's 2/3, maybe it's 3/4. I can't tell. So I'm going to go over to this first point where I definitely have a nice whole number x value, 2 pounds, and that corresponds with a definite whole number y value, 1 hour. So look for those whole numbers. You do not need to put every single amount of pounds in this table. We're going to say 2 pounds is 1 hour. Where's the next time that we have an x and a y value that correspond with whole numbers here? So we're not somewhere in the middle. Well, it looks like 4 pounds and 2 hours. 4 is my x value, 2 is my y. The next one would be 6 pounds and 3 hours. Can you predict what my next one I'm going to record is going to be? Where does it cross? And an x value and a y value with a whole number. Well, 8 pounds and 4 hours would work. And then finally, Will 9 work? No, 9 looks like it's in the middle of hours here for 9 pounds. So I'm going to go to 10 pounds and up to 5 hours. So 10, 5. Now that I have those values, again, we're going to aim for about 5 of them in the table. We're going to go ahead and go to our equation. Can we find a pattern here? What's happening to x each time? Because we want to say y is doing something to x. Y results from doing something to x. So 2 becomes 1. So is it take away 1? Well, 4 minus 1, that doesn't give me 2. Looks like that doesn't work. It's getting smaller. 2 becomes 1, 4 becomes 2, 6 becomes 3, 8 becomes 4, 10 becomes 5. So it looks like it's half as much each time. So you could say y over, let me say x, right? X divided by 2. Typically, you're going to see it written as a multiplication problem, at least here in 6th grade. So what's another way that we could say x divided by 2? What's the same thing? What's equivalent? Well, if you divide something by 2, it's the same as a half. So we could say y equals half of x. So I'm going to challenge you again. What if I skipped way ahead and I had this giant roast? It was 20 pounds. So that would be my x value, 20. How many hours would we have to cook that for? Use the equation. Well, half of x, half of 20 would be 10. That's the nice thing about knowing the equation is you can plug in any x value you want and figure out what your y value would be. Here's our last one. Latrell's reading. He reads for a certain number of hours. There's time again on the x-axis, and he reads a certain number of pages. Notice what's different about this graph. When you go up the y-axis, it's not counting by ones anymore. It's jumping up by how much? What are we increasing by each time here? Well, if you said 30, you're correct. So keep that in mind when we record our values. I'm going to do the same thing. I'm going to look for an x and a y value where they meet at whole numbers. If I go over to 1 hour, so there's my x value on the x-axis. It looks like 60 pages. Well, he's a pretty fast reader, about a page a minute. Hey, there's a unit rate for you. Lucky you. How about our next x value? If I go over to 2 for my number of hours, how many pages does he read in 2 hours? Well, if you said 120, you are correct. 3 hours, what's my y value going to be there? I'm just going to follow that up until it has a nice whole number there on my y-axis. 3 hours is 180. Now, I know I said to aim for 5. This graph only goes up to 3 x values. You could predict what 4 and 5 can be. In fact, we'll do that at the end. But I think we have enough data here where we can see what's happening to x each time. So I'm going to say y equals x, and we'll record what's happening to x. Let's see. I'm not going to be fooled this time and say it's adding 59 each time, because that's not true. It only works for the first time. 1 becomes 60, 2 becomes 120, 3 becomes 180. You can use your basic facts. How's 1 related to 6? How's 2 related to 12? How's 3 related to 18? Well, I know that 1 times 6 is 6, and 2 times 6 is 120, and 3 times 6 is 180. So since this is one place value greater, right, we're going to say it's 60. 1 times 60, 2 times 60, 3 times 60. So how could we write that equation? Y equals, what are we doing to x each time? You could say x times 60, the algebraic way, easy for you to say. To write that would be 60x, because that means multiplication. We're multiplying our x values by 60. So what would our value for 4 hours be? How many pages could Latrell read? And what would it be for 5 as well? See if you can figure those out. Keep working hard. Keep staying focused. Listen to your math teachers. You're going to do a good job.